The first four terms of a sequence are shown in the table below. The sequence is defined by a sub 1 equals 2 and a sub n equals a sub n minus 1 plus n minus 1 squared for n is greater than or equal to 2. What is the sixth term, a sub 6, of the sequence? So first, let's break down what this rule means, and then we'll talk about how to actually solve it. So this you should be familiar with at this point. A sub n is the value of any term, right? Any nth term. This here, a sub n minus 1, stands for the previous term, right? Because if this position, if n was like the fifth term, n minus 1 would be fourth. So this would stand for the fourth term, right? So that's kind of the first key thing to recognize. So now let's take a look at this actual sequence here. One thing we always want to look at is just, are the numbers increasing or are they decreasing? They're definitely increasing. And we can kind of just take a quick peek by what, like how the numbers are changing. This tells us the actual rule. So of course, this is what, what it's defined by. We notice it's not an arithmetic sequence, right? Because this is like a +1, then this is +4, then that's +9, right? Which is really what this rule is telling us. It's the previous term plus the index -1 squared, right? So like +1, +4, and +9, right? And +4 is 2 squared, and then +9 is 3 squared, right? Just so you can kind of start to like visualize that. So if you're comfortable with that, we could actually just continue that pattern on. So the fifth term would be +4 squared, which would be 16, right? So then this next term, 16 plus 16 is 32. And then our sixth term would be +5 squared, so +25. 32 plus 25 is 57, right? The other way we could do that is we could actually just use this, really just this rule here. It's the same thing I just did. It's just a little more algebraic rather than conceptual. So what we would have to do to get the sixth term, a sub 6 equals a sub n minus 1. So that would be a sub 5 plus n, in this case, is 6. 6 minus 1 is 5. 5 squared is 25. However, we would have to do this again because we don't know the fifth term, right? So then we would have to do a little sub problem. The fifth term is equal to the previous term, which is a sub 4, plus my n again is 5. 4 squared is 16. And then my fourth term is 16. So that would be 32, which is exactly what I found here doing this conceptually. Then I would take that, plug it back in here to get a sub 6 is 57. So whatever works for you. A lot of the times with sequences, I find that doing it conceptually works just as well as plugging it in. But if you're the type of student that likes to see things kind of written out using formulas, I think this technique may work better. All right.